Chapter exercise 35. Question number 2. Consider the following enthalpy change cycle A, B, C, and D. Which of the following expressions is the correct relationship among the enthalpy changes A, B, C, and D? Now bear in mind, use two highlight pens to highlight the roots, the steps that belong to the same root. You may consider the directions of the arrow. This one is clockwise. Can you see that? And then followed by this one is also clockwise arrow. And then for B and C, they belong to anti-clockwise. Therefore, they belong to another root. So A plus D should be equal to B plus C. Okay? A plus D is equal to B plus C. Therefore, the answer is D. Do you understand? Question number 2. Number 3. Which of the following is the center enthalpy change of formation of Na2O solid? Now bear in mind, first of all, use green highlight pen, highlight your target reaction, standard enthalpy change of formation of N2O. Firstly, you must, based on the definition, change these terms into equation. It is the enthalpy change when 1 mole of Na2O is formed from its elements. Its elements are sodium solid and O2 gas. Bear in mind, keep these coefficients as 1. Therefore, 2 should be put before Na and half should be put before O2. In this question, you are required to work out this delta HF. Okay? And then look at the data given. Given that heat of formation of Na2O2 is, and this one is negative 88 kilojoule per mole. Okay? Now you may solve this problem by drawing cycle or by using elimination. First of all, you are required to change this term into equation. Heat of formations of sodium peroxide is the enthalpy change when 1 mole of sodium peroxide is formed from its element. Its elements are sodium and oxygen with formula O2. Next, balance this equation. Bear in mind, according to the definition, we need to keep this coefficient as 1. Therefore, we need 2 Na and 1 O2. This delta H is given, which is negative 505 kilojoule per mole. Okay? Next, another data given is Na2O, half O2, and Na2O2 with delta H equal to 88, negative 88. The first one, negative 505 kilojoule per mole. How to solve this problem? Bear in mind, this is your target. Okay, now I show you two methods. The first one, by elimination. That means you're required to work out our target reaction. Write down the target reaction. And then we need to calculate its delta H. And then look at the equation given. Here we have 2Na. So simply copy down the first equation. No need to change its direction. No need to multiply by a cofactor. Therefore, delta H is equal to negative 505. Next, we need to cancel out Na2O2. Here we have Na2O2. So we need to reverse the second equation. Simply reverse. No need to multiply by a factor. Because I have reversed the equation, so the delta H changed from negative 88 to positive 88. Next, let's check. In summing these two equations up, there is one Na2O2 solid and another one on the reactant side. So we can cancel them out. Next, we have 2 Na. We have 1 O, but there is half O2. So simplified becomes half O2 on the reactant side. We have 1 Na2O on the product side. Therefore, the delta H is equal to negative 505 plus 88. Do you understand? Use your calculator. The answer is negative 417 kilojoule per mole. Can you follow? This is the first way. The second way is to draw an enthalpy change cycle. The second method. How? Again, first of all, focus on your target reaction. This is your target. Copy down this equation horizontally. And then next, look at the equation given. We have 2. Now, we have 2 Na react with O2. Therefore, I will start my cycle by drawing from this direction. 2 Na react with 1 O2. However, we have only half, so I need to add half more. After that, Na2O2 is produced. Okay? Because I haven't multiplied the equation or changed its direction, so this delta H1 is equal to negative 505 kilojoule per mole. Next, let's look at another one. We have Na2O, Na2O. We act with half O2. Now, here we have half. In the cycle, everything is balanced, so we need to add half more. On the other hand, you may consider we have Na2O, we act with half O2 to form Na2O2. Again, I haven't multiplied the equation or reversed its direction, therefore I label it as delta H2. Delta H2 is equal to negative 88 kilojoule per mole. Can you follow? Next, take out a highlight pen, highlight. This is a clockwise arrow. This is a clockwise arrow. They belong to the same root. And then this one is the anti-clockwise arrow, belong to another root. According to Hess law, delta HF plus delta H2 is equal to delta H1. That means delta HF is equal to delta H1 minus delta H2. Substitute the data into the equation, then you can work out the answer. Delta H1 is negative 505 minus delta H2 is negative 88. Therefore, the answer is negative 417 kilojoule per mole. The answer is boiled. Do you understand?